Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2010 Calculus BC question number 6 from the free response questions. And this question was strictly for BC only because it is revolved around Taylor series and error bound. And the problem reads, we have a piecewise function at the top, f of x is equal to those two things, revolved around 0. The function f defined above has derivatives of all orders. Let g be the function defined by g of x equals 1 plus the integral of that thing. And part A, it says write the first three non-zero terms and the general term of the Taylor series for cosine of x around x equals 0. And then use this to write the first three non-zero terms and the general term of the Taylor series of f about x equals 0. So the basic gist of this problem here is that we're going to use a bit of Taylor and Maclaurin manipulation in order to convert our standard cosine into the cosine x minus 1 over x squared. And so how do we do that? I'm going to go and just get my first few terms of cosine first. So if you know your power series very well, then you'll know that this is going to be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. Now they're asking me for the first three non-zero terms, so I have satisfied that. And then they want the general term. Now let me tell you what you're going to do, because this is what you're thinking. I know what you're thinking. You're going to go plus dot dot dot, and then you're going to say, I want to sound smart. I want to do sigma notation from k equals 1 to infinity, and then I'll go and throw down the negative 1 to the k minus 1 for the alternator. The x will increase by, it has a slope of 2, so I'll say 2k, and it's going to be plus 2 each time, so 2k, or actually, I'm sorry, not plus 2, I mean minus 2. Minus 2 each time. And then the exponent and the factorial correspond, so we'll get that down there. Now I know what you're thinking. You're thinking that that sounds good. The problem is that if you do this, you're saying 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus dot dot dot, and then this entire series yet again starting from k equals 1. That's bad. You are duplicating some of your answers. If you do this on the AP exam, you are in line to get it wrong. You do not want this sigma here if you're going to do plus dot dot dot. If you really want to include the sigma, just put the sigma notation underneath the series, and then that will allow you to write the sigma down appropriately. So it's up to you either way. If you're going to leave it up top with the plus, then please make sure you get rid of the sigma so that you don't end up with any kind of misuse of equality or linkage error or something like that. You don't want to unearn points that you really do deserve. So we'll go and just leave it sigma-less in this example here. And so from here, now that I've gotten that little rampage over, I'm not done yet. Those are the first three terms and the non-zero terms and the general term of cos x. But remember, I'm going to do the cos x minus 1 over x squared. So let's take this in phases. I'm going to just do cos x minus 1 first. Well, and I'll go and switch the colors here. It's fine. I'm going to save the general term for the very end. And so cos x minus 1 is going to be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. But then that's all going to be subtracted by 1. So as you can see, what's going to happen here is that the 1s are going to cancel each other out, leaving me only with x squared over 2 factorial plus x to the fourth over 4 factorial. I'm sorry, the x squared is negative. And so the problem with this is now I don't have three non-zero terms anymore, so I have to now recognize the pattern of how this goes, or really just know the power series of cosine, and it is my responsibility to now add another non-zero term, which is going to be subsequently minus x to the sixth over 6 factorial. Now again, this has to be added in at the end because of the minus 1, that would cancel out with the positive 1. So we're not done yet. Now I have to take this whole shebang and divide him by x squared. So that's going to be, and I'm going to switch colors for this one as well. I'll switch over to sky blue. So that means that cos x minus 1 over x squared. Now notice my progression here. Cos x really just equals this thing. Cos x minus 1 really only equals this thing. I'm not putting all of these things together because I don't want to end up with a misuse of equality. So cos x minus 1 over x squared takes all of these guys and multiplies them by either 1 over x squared or divides by x squared. So if I divide everything by x squared, I will end up with 1 over 2 factorial plus, again, x to the fourth over x squared is going to be x squared over 4 factorial, and then x to the fourth over 6 factorial. All of these exponents get reduced by x squared. And now what I'm going to do is I'm going to say, okay, plus dot dot dot, and now I'm going to throw down my general term finally, which is going to be, again, negative 1 to the k this time, because, and it's to the k because I'm starting at k equals 1, which means my first term is going to be negative. And then it'll be x to the 2k minus 2. Again, my slope is 2. And then it'll be 2k minus 2, or rather 2k factorial on bottom. Okay, I believe that takes care of A. Let's go ahead and move on to B. Question B reads, use the Taylor series for f about x equals 0 found in part A to determine whether f has a relative min, max, or neither at x equals 0. Give a reason for your answer. Okay, relative mins and maxes, I can do that. That's going to be the first derivative right there. I'm going to do the first derivative. So f prime of x is going to be, well, this constant up here is going to go away. It looks like I end up with just 2x over 4 factorial minus 4x cubed over 6 factorial. Now from here, I could do a sign chart on this thing if I really wanted to. The problem is, setting them equal to 0, solving for x, that's going to be a big pain, especially with these factorials here. I don't want to deal with that. But luckily, there is another test that I have up my sleeve. I can go ahead and use the second derivative test on this thing. So what I'm going to do is I'm going to find out what f prime of 0 is. And again, if I'm a lazy calc student, I don't want this thing to equal 0, because then I can just say neither, but we'll see what happens. I think it's 0, so unfortunately, I'm going to have to use the second derivative on this thing. So how does the second derivative test work? I'm going to switch colors here. I'm going to take the second derivative of the function. That gives me 2 over 4 factorial minus, looks like 12x squared over 6 factorial. And I'm going to say, all right, well, what is my concavity when I'm at 0? Well, my second derivative is 2 over 4 factorial, meaning I am a positive number. So to put these two things together, the idea of f prime being 0 means that I'm flat. The idea of f double prime being 0 means that f is concave up. So if I'm flat and concave up at the exact same time, there's only one possibility, and that is that I have a local min. So I can say, therefore, f has a local min at x equals 0, 0, and I can probably circle this and keep my justification there. But if you really want to justify, you could say because of these reasons stated above here. So I would box this as my final answer here. Again, my first derivative is 0, my second derivative is positive, and they don't really even need this drawing here. I think you could just conclude with the words. I think that would be good enough. Okay, let's go and read part C. Part C says, write the 5th degree Taylor polynomial about x equals 0. I'm going to need some space for this. I'm going to pause this real quick, and then we will come back. All right, let's go ahead and take a look at C now that the board is all cleaned up. It says, write the 5th degree Taylor polynomial for g about x equals 0. So when I tackle Taylor polynomials, I like to just write out the generic Taylor polynomial. So I know I've got g of 0 plus g prime of 0 x plus g double prime of 0 x squared over 2 factorial plus g triple prime of 0 x to the third over 3 factorial, and down the chain we go all the way until our 5th derivative here. Rather tedious, but it cleans up kind of well. I will say this problem is, part C is probably the most time consuming of them all. In order to do this, I'm going to go and scroll down, and I'm going to just go and come up with some kind of like assembly line, if you will, over this. This g of x is going to play a role in this problem here, and so is f of x. So I'm going to rewrite that, the f of x Taylor polynomial. So this is going to take me a little bit. Let's go and scroll all the way down here. I'm just going to put all of this stuff. At the end of the day, I hope it makes sense, we're going to need up to 5 derivatives of g. So I'm going to go ahead and make that list now. So I'm going to say I need to find out at the end of the day g of 0, g prime of 0, g double prime, not triple prime, sorry, g double prime of 0, g triple prime of 0, g quadruple, and g to the 5th derivative. Okay, so whatever I produce in this list is going to end up popping back in to become the coefficients of the other thing. So I'll go and disregard him for now. Well, we know that g of x is equal to 1 plus the integral from 0 to x of f of t dt. We know that because the problem says that in the prompt. We know that f of x is going to be the Taylor polynomial of this thing. So we know that that's going to be negative 1 over 2 factorial plus x squared over 4 factorial minus x to the 4th over 6 factorial, and then plus dot dot dot. Now we found that out in part A, right? So I'm hoping that we remember that. Okay, so let's find out what g of 0 is. Well, g of 0 is pretty easy because that means that this integral is going to go away. So g of 0 just equals 1. So I'm going to scroll over here. Hopefully I don't make people seasick with all the scrolling over and stuff like that, but if you get seasick with all the scrolling over, then just take some motion sickness medicine here. So we know that g of 0 equals 1. Okay, cool. So actually I can go and get rid of him because that's what we made the table for, so we don't have to worry about this guy. All right, let's worry about g prime of x. Well, g prime of x is f of x, right, using the second fundamental theorem of calculus. And that's the slope anywhere, but in this case I want the slope at 0. So what is f of 0? F of 0 means all of the x terms are going to go away. So I hope it makes sense that f of 0 here, or g prime of 0, again, I'll just go ahead and just reiterate the connection here. That's going to be negative 1 over 2 factorial, or negative 1/2. Okay, so from here, let's keep on going. G double prime of x is f prime of x. Well, what's f prime of x? Well, f prime of x is going to be, the constant's going to go away. I end up with 2x over 4 factorial minus 4x cubed over 6 factorial. This is a good thing because I know that f prime of 0, according to this, is going to be 0. Excellent. I like when things are 0. Okay, so motion sickness continues. G triple prime of x is going to be f double prime of x. What's f double prime of x? Well, let's go and derive it. That means I get 2 over 4 factorial minus 12x over 6 factorial, sorry, 12x squared. F double prime of 0 is going to make this x term go away, so I end up with f double prime of x. So this is f double prime of, sorry, not x, but 0. I believe that was 2 over 4 factorial. So you see how I'm just kind of going down the chain. There's not a whole lot of math going on here. There's a little bit of motion sickness, but I apologize. So g4 of x is going to be f triple prime of x. Well, again, the constant's going to go away for f triple prime, and I end up with 24x over 6 factorial. Perfect. g4 of 0 is 0. And I think you guys can kind of see the pattern here. I don't know of a faster way to do it, but if there is, please let me know in the comments. I'm all about improving speed. The fourth derivative of x is going to be 24 over 6 factorial. Nothing to plug it in, whoops. And that's going to leave me here 24 over 6 factorial. Okay, so all these terms that we just found, all of these terms, this 1, this negative 1/2, this 2 over 4 factorial, this 24 over 6 factorial, those are all the coefficients of this dude that we abandoned so long ago. So from here, we just plug those things in. So what I get is 1 minus 1/2 x. This dude's going to go away. He's 0. We don't care about him. This guy's going to become plus 2 over 4 factorial. So plus 2 over 4 factorial, x cubed over 3 factorial. Again, where am I getting the coefficients from? It's from that little assembly line that we did down there. This dude's gone. We don't care about him. And all we're left with is negative 24 over 6 factorial, x to the 5th over 5 factorial. And I believe that coincides. Are we good? Are we good? I feel like I made a mistake. Yes, I did make a mistake. This is negative. And so this is negative right here also. My apologies. And this long-winded deal here is our 5th degree Taylor polynomial about x equals 0. So if you wanted to, you could just kind of clean him up and simplify him if you wanted to. You could throw down like a big plus sign here and a big minus sign here. Now, at this point, I would probably not simplify anything because on this year's AP test, there is no error bound, whether alternating series or Lagrange. However, we do know alternating series error bound, and because we know it, I'm actually going to simplify this thing and do part D. So let me go and clean up all the madness that went on down here. You served your purpose, and now I do not need you. So I appreciate you being here, but be gone. Be gone, Scott Pilgrim said to the vegan. Okay. Oops. All right, so let's simplify this thing a little bit here. So I've got 1 minus 1/2 x plus, okay, 2 over 4 factorial. This is 4 times 3 times 2 times 1 times 3 times 2 times 1. The 2's can cancel each other out, giving me 4 times 3 times 3 times 2 times 1. Let's see here. What is that? And that would be 72. So plus x cubed over 72 minus, okay, I've got some craziness down here, so let me see if I can't figure this thing out here. So this is going to be, okay, so this is, you know what I'm going to do? I'm going to do something easy. 6 factorial times 5 times 4 factorial, and I know that 4 factorial is 24, so he can be gone. So I can say x to the 5th over 6 factorial times 5. Okay, and I'm not even going to bother with this guy. Whatever, I'll leave him there. If I need to simplify him, I'll do it later. It's just 720 times 5, I think. Okay, cool. So that's part C when everything is all said and done. So let me go ahead and move on to part D. Part D says the Taylor series about x equals 0 evaluated at x equals 1 is an alternating series with individual terms that decrease in absolute value towards 0. Use the third degree Taylor polynomial for g about x equals 0 to estimate the value of g of 1, and explain why this estimate differs from the actual value of g of 1 by less than 1 over 6 factorial. Okay. So, alternating series error bound. So what we want to do is, they told us that the terms alternate and decrease in absolute value towards 0, but because they told us that, we need to say it again before we establish the use of alternating series error bound. So we can say series alternates and decreases in absolute value toward 0. Oops. I always missed the 0 button. I always make it the minus. Okay, so this right here is our gateway into using alternating series error bound. So what do they want us to do? They want us to use the third degree Taylor polynomial about x equals 0 to estimate the value of g of 1. Okay, so remember, when it comes to alternating series error bound, we're going to use a finite number of terms to estimate an infinite sum. So what I'm going to do is I'm going to use the third degree version of part C, which is all the way through x cubed. I'm going to add those 3 things together, and then that's going to be my estimation. So t of 1 is going to be 1 minus 1/2 plus 1 over 72. Now from here, if I go and simplify that all the way, I'm going to get a common denominator. So 72 over 72 minus, let's see, 36 over 72 plus 1 over 72. So that's going to be 37. So that's 37 over 72. And this is my estimation, right? Remember, this is my finite estimation here, my guess. Okay. Now, of course, my guess will have a degree of wrongness. We have to find out what that wrongness is. But I know that the wrongness I'm going to be, I know that whatever g of 1 really is minus my estimation, oops, not 27, 72. My actual, this is my actual value. This is my guess, my estimation, right? The difference between them in absolute value is going to be what my actual error is going to be. Well, that is always going to be less than something, and I want that to be less than 1 over 6 factorial, because they told me, they said they wanted to be less than 1 over 6 factorial. They said that in the question. Well, remember what goes inside the center here. Everything that goes inside the center here, this is what the error bound is, right? Remember, my actual error will always be less than my error bound, according to the alternating series error bound. So what is my error bound? Well, remember, my error bound is always the term that happens after my last term of my guess, which is going to be this guy. And if I evaluate this dude at x equals 1, what I get is I get 1 over 6 factorial times 5. Now, is this true? Is 1 over 6 factorial times 5 less than 1 over 6 factorial? It is, because we have a larger denominator, meaning we have an overall smaller number. So what I can say then is, using alternating series error bound, our estimation will be less than, I'll write this part out because I can't do this on the typing, 1 over 6 factorial. And I believe that will wrap it up for this crazy FRQ. As always, please leave comments and questions in the comments area, and I will see you in the next episode.